Hello, 11th grade. This video is to go over the periodic function review problems that were posted on Tuesday. Just to recap what Ms. Stang has presented in lessons, here is a graph of a periodic function. Think about where it cuts on the y-axis. Here at 5, and because it cuts the y-axis above the mean line or below the mean line, kind of at that maximum, or if it was reflected, it would be the minimum point, that tells us that we have a cosine function. So this is cosine wave. Now, if you think about where is the middle, what would cut this in half? That is your principal axis, that is your mean line, and in this case we can see it's 3. Then if you go up from the mean line to the maximum, or down of the mean line to the minimum, we see that that is 2. And so that's why the amplitude is 2. It's the height from the principal axis to the maximum, or the height to the minimum. Now, the period, that's the other important piece of a periodic function. The period is one full wave. Well, when you've completed one full wave, how many degrees have you gone? Usually 360 degrees. One full wave means you start somewhere. Let's get some paint in here. Say we started right here, and then went up, and then went back down, and then got back to where we started. That is one full wave. And in this case, it took 4 spaces. Remember, it's a period of 4. Okay? That period is important. When we look at the equation, we don't see the period in the equation. We see the amplitude. So let's get some highlighters out here. So here's your amplitude. That's that height from the principal axis to the maximum or the minimum. Then we also see, pun intended there, we see the principal axis. And that's always a line in the form of y equals something. But we don't see the period. The period is, again, usually it's just one full wave. Well, this B right here in the middle, this B tells us the number of waves we get in 360. So let's start looking at some problems. This first one, we see a couple graphs. We need to identify the period, write down the value of P, which is the amplitude, and then also write down the value of Q, which is the number of waves in 360. Then we need to estimate 3 solutions, and those 3 solutions are the intersections of these 2 graphs. So we'll write down their values. And then the last thing I want you to do, I want you to think about the model in all of these examples. We want to write the model of f of x. So we want to write the model of this curve, the cosine curve, right here. There's one full wave. Notice it took 240 degrees. Let's look at the answers. So first of all, the period is 240 degrees. We can see that on the graph. And then what is the value of P? Well, one wave is 240 degrees. Well, how much of a wave is in 360 degrees? So we just create a ratio, and we can see it's reduced to 2/3. Okay? So that is the value of Q. Now the value of P, was the amplitude. So that's 1.4. That's an estimate of about 1.4. All of these increments between 1 and 2 are going up by 2 tenths. So this is 1.2, 1.4, 1.6, 1.8, and 2. So 1.2 to the mean line, which is 0. And then calculate the value of Q. Again, number of ways in 360, and that is 2/3. Then we need to estimate where are these intersections. And I've estimated at about 60, 160, and then 340, and then wrote down their Y value estimates. Now, taking the amplitude, the value of Q, the number of waves in 360, and the principal axis, which is 0, here is your model. The next question gives you a model, and you have to pull out some information from the equation. So if we think about the depth of water in a harbor, it's modeled by a sine wave. Now we have to keep in mind that the time is 0 to 1440 in minutes. So first thing, the amplitude is 4, and we can see that number from our equation right here. And then what is the maximum value of D? Well, we don't have a graph to look at, but you could easily type this into the graphing calculator. But what you want to think about is the middle is 7. So if the middle line is 7 and we went up to the maximum, we would add 4 and 7, and that gives us to 11. Then the period, well, it tells us that half of a wave is shown in 360. So one full wave of a period is twice that 360, which is 720 minutes, also known as 12 hours. And that makes sense because if you think about temperature, or things rotate on that 12 hours. Now, part C, this minimum, there seemed to have been an error there. So I found this problem in an old IB textbook, and I would just ignore part D. It doesn't make sense. Next question. Here we have a graph, and we have a model that is incomplete. First of all, take a look at one full wave right there, and we see that's 180 degrees, so that's the period. And then from there, we can look at the graph and think about that period to find the A, the B, and the C. Then we're going to write the model. And then we're going to write down the solutions for when f of x is 3. And that means where does the curve intersect this line, but between 90 degrees and 270 degrees. So I don't care about this part or this part. I just want from 90 to 270 degrees. And so that means I'm only going to be concerned with these particular intersections. So right here and right here, because that's the only where on this curve that it intersects between 90 degrees and 270. Let's take a look. So first of all, you can see one full wave is 180 degrees. And then A is your amplitude. So you can see that line, that distance is 3. And then 180 degrees is one wave. How many waves would show up in 360? Well, you can see that there's 2. Here's one, and then the other. There's the second. So B is 2. Now, last thing, where is that mean line? Where is that principal axis? That's at 1. So f of x is 3 times the sine of 2x plus 1. That is your complete model. Then if we estimate where these intersections are, I estimated this one at about 200, and then this next one at about 245. Consider yours correct if you were within, say, 5 to 10 degrees, maybe 1 to 5 degrees off between 200 or around 200 and 245. This next question talks about temperature, which is a common application of periodic functions. We know it well in Minnesota. So we look at the temperature in Celsius over a 24-hour period. We have a graph, and we have a model that is not complete. First of all, let's look at A. That's our amplitude. B is the number of waves in 360, and then the principal axis. And then we're going to write down the interval of time when the temperature fluctuates between -4 degrees and -2 degrees. And then last, we're going to write the model. So let's take a look at our solutions. So here we can see that the amplitude is 1, and 1 wave occurs in 24 hours. That makes sense. You know, the same time right now from 24 hours from now is likely going to be the same temperature. We're around there. So 1 wave is 24 hours. So how many 24-hour waves will occur in 360? That's just a proportion. What's 24 times 15? That gives us 360. So that tells us that we have 15 waves of time of this temperature in 360. And then lastly, we can see our principal axis right here is -3. And then write down the interval of time during which the temperature is increasing from -4 all the way up to -2. So let's look at where that pattern is. So here's -4, and we want the increase to go up to -2. Well, that occurs between 16 hours and 20 hours. 16 and 20. It includes both of those values, so that's why it could be equal to in both those scenarios, yes. And then write the temperature model. Well, 15 waves in 360. Amplitude is 1. Feel free to write that 1. It's not wrong. It's just not necessary. And then principal axis is -3. So y equals the cosine of 15t minus 3. The next question deals with the height of a bicycle pedal as it's being pedaled above ground. So here's your graph. We need to talk about the maximum and the minimum, and then find the amplitude, the period, and find the number of waves that will show up in 360. That is your B. So from the graph, we can easily see the max is at 35 centimeters, the minimum is at 5 centimeters, and we can find the amplitude by looking from the mean line of 20 up to 35, or from the mean line of 20 down to 5. Each way, there's a difference of 15 and 15. Okay, so that's why the amplitude is 15. Then the period of the function, in other words, where is one full wave? Let's get a different color here. How about green? Ooh, that's big. So from here all the way to where it starts repeating, that took 4 seconds. Well, how many waves could 4 seconds long show up in 360? Well, there's 90, because 4 times 90 gives us 360. So the B is 90. This last question gives you a model. It also gives you a domain. Because it is an x value, that is your domain. We need to write down the period of the function, the minimum, the range, and find one solution where the graph or the function goes through 1. Now the period, look at what is right next to x. Here. That tells us there's 1 wave in 360. And so that means the period is 360. Then write down the minimum of the function Well, let's think about it. First, where is your middle axis? -1. That's your mean line. We know the amplitude is 2. So to get to the minimum, we've got to subtract 2. And so the minimum value will be at -3. And you can see this if you plugged it in your graphing calculator. I'm actually going to show you that in a moment. Then, what is the range of the function? Well, -3 is going to be the lowest. But if we take that mean line all the way up to the maximum, that's -1. The mean line, which is -1, plus the amplitude, which is 2. -1 plus 2 is 1. So the range of the y values are between -3 and 1. And then lastly, find one solution to f of x equals 1. Well, 90 degrees will do it, or 450. And let's look at why 450 works as well. So using the graphing calculator, first of all, make sure you're in degree mode. Then enter your equation into the y equals section. Now, they gave you a domain, so use that. Notice that I have that right here, from 0 to 720 degrees. And then if you mark each tick at 90 degrees, you'll see a beautiful graph like this one. Okay. Now, we can estimate. Notice at 1, this is your first mark of 90, right there. But then we have another one over here. And now, consider another y value. How many more degrees until the function completes a full circle? In other words, one more weight. That's 360 degrees. Well, what's 360 plus 90? That's where we get 450. And we could also go to our table, second graph, and go down to 450, and we would see that it's a value of 1 as well, not just at 90, but also at 450. And it will keep going. Think about what other values what other degree values will produce a y value of 1. Keep following that cyclical pattern of one full circle is 360. Thank you for watching the video.